Okay, today we're in section 6.3, two-way tables. 6.3, two-way tables. And a two-way table displays, let me unfreeze that. It displays two categories, all right, so that's important, of data collected from the same source. All right, so this isn't, schools-wise. I think one of our examples talks about schools. It's not data from one school and data from another school. No, it's from the same source or the same population base. All right, but it's two categories, and these categories cannot happen at the same time. All right, it's either one or the other. And you'll see more about that in just a minute. So each entry in the table is called a joint frequency. You need to know that. So if I say something about the joint frequency, you need to know that that just means each entry. All right. The sum of the rows in a table are called marginal frequencies. All right. So this is actually a pretty simple concept, but if we don't know what marginal frequencies means, then we're going to have a hard time identifying, like I said, a fairly simple concept. Okay, so in example 1, I have a two-way table down here. I need you to write this two-way table and make sure you leave room around it. We're actually going to kind of build the table out a little bit by one more column and one more row below it. So give yourself some space, all right, around this table. But I need you to go ahead and write it down on your notes. All right, so we have two categories here in the two-way table. We have students, and then we have grades, all right, students and grades. And of these students, some studied and some did not study. And of the grades, some passed and some failed. All right, so we're going to take a look at this information and see if we can draw any conclusions from it. Okay, so we should be just about there, at least, or almost done. All right, let's go, wake up. All right, pay attention. All right, so now let's answer the questions. We're just going to read the chart and answer the questions. And the first, or not the first, but numbers 9 and 10 on your homework are simply just answering the questions. That's all you have to do on 2 of your homework problems tonight. How many students in the survey below studied for the test and passed? So look at your studied column and your passed column or row, and how many students meet the criteria? 21. So that's the number that you would write for your answer. 21 students studied and passed. All right, I want you to go ahead and answer the second one on your paper. All right, so you're going to find the column that it asked for, and then you're going to find the row, and you're going to see what number matches that column and row. How many students in the survey studied for the test and failed? How many students studied and failed, guys? 1. Okay, and we'll talk more in a minute about maybe some interpretations that we can make based on that information. All right, so just reading it and answering a question. Any questions there? Okay, so that's one part of it. Now in example 2, we're going to take the same information and now we're going to establish our marginal frequencies and make an interpretation. Marginal frequency, and you might want to write this down in your notes. It's a fancy word for total. Totals. That's all you want. On your quiz, it's going to say marginal frequency. If you forget that that means something as simple as total, then there's no way you can get it right, okay? So that's one thing that you do need to learn. Totals for each row and totals for each column. Okay, that's all we're doing here. All right, so I've got total. All right, so for the studied column, how many students studied total? 22. I just add them together, straight down. How many did not study? 8. Yeah, 2 plus 6 is 8. All right, I want you to write in your totals for passed and failed. How many students passed total and how many failed total? All right, so how many passed? 23. And how many failed? 7. And I know that for sure that my totals are correct if both of them add together to be the same total. If I can add my columns together, what's 23 plus 7? 30. And what's 22 plus 8? 30. So if I can add them across and up and down to get to the same total, I know that I've calculated my marginal frequencies correctly. You with me so far? Yeah. Okay. Now we need to make some interpretations. All right. If I just say the total is 22, that doesn't really mean a whole lot. I need to name the category. We talked about this yesterday in lines of fit, that our interpretations don't mean anything unless we name the category. 22 means that 22 students studied for the test. All right? So I'm just writing that in words. Studied. How many did not study?
8.
And 8 did not study. I'm putting it into a sentence. All right? Now I want you to take the past failed categories and put that into a sentence. How many students passed? 23 students passed. And how many failed?
7.
And 7 failed. Okay. And then the last part of this part of the interpretation is how many students total were surveyed? 30 students were surveyed. Okay. Now, this is the most important part of the interpretation. I need to make some kind of a conclusion about this data. Why am I comparing these two categories together in the first place? Why not compare their grade with what color shirt they were wearing that day? Oh, blue shirt? Oh, you failed. Black shirt? Oh, you didn't pass, or you passed. Why would I compare grade with whether they studied or not? Elizabeth?
Because it makes a difference in the data.
Okay, well, you're kind of on the right track in your thinking. Sherelle? Okay, so I see a pretty high category up here, don't you? Okay, so what this data is showing me is if you study for the test, you have a really strong chance of passing. Would you agree? Yeah. And most of the students in this class, out of 30 students total that were surveyed, how many of them studied? 21. That's 2/3. I mean, that's not a great statistic. All right, 2 of them, maybe you could call it luck, did not study and still passed. But my interpretation is the majority of the students who studied passed. All right. Any questions on this part of it, the interpretation part? Again, data means nothing if I cannot interpret it. If I can't say, well, this is what it means, or this is what it's showing me. So I would definitely say that was probably my clearest interpretation. It's not the only interpretation you could have made from it. Okay? You could have said more students studied than did not study, or more than twice as many students studied versus not study. There's a couple other interpretations you could have made. Okay, so let's move on to example 3. All right, in example 3, we're making our own two-way table. I took it straight out of the book. One issue I have with it is it's not completely even. Okay, we have some information here. We have tallies for kids who ride the bus and tallies for kids who don't ride the bus. And then we have ages. However, there are 3 categories of ages. Okay, so it's not the 2 and 2 comparison from the first example. Well, one of these categories actually has 3 intervals that we need to fill in. On a quiz or a test, I would make it even, okay? And one thing I need to make clear, and hopefully this is not confusing to you, it technically does not matter if I put age on top or age on the side, or if I put the students on top or the students on the side. They can switch back and forth. So you don't have to worry, oh my goodness, like which one do I put on, the top column versus the side. Technically, it does not matter. All right, so the way I have mine set up, this one's going to be my age. This one's going to be my age. And then over on the side, I'm going to have my categories of kids who did the bus, rode the bus, or did not ride the bus. Okay? And now I need to set up the rest of my intervals. Okay? And I need to start writing my totals from the tally chart. Okay? So I'm going to go ahead and label my columns. 12 to 13. 14 to 15, and 16 to 17, okay? So here's what I'm going to do. Between the 2 tables, how many 12 to 13-year-olds rode the bus? You're going to write that total in the block. How many 12 to 13-year-olds did not ride the bus? And then you write that total in that block. All right, so let's go ahead and transfer over. Again, guys, it's just a matter of being able to read this to the point where we can actually make interpretations. Seeing a bunch of tally marks doesn't really do a lot for me, okay? That doesn't help me draw my conclusions. So seeing actual numbers is a lot more helpful. All right, so let's go ahead and start writing some of our totals. So how many 12 to 13-year-olds rode the bus, guys? 24. How many did not ride the bus? 16. So how many total 12 to 13-year-olds were surveyed? How many were surveyed? How many 12 to 13-year-olds were surveyed? 40. 40 were surveyed. Okay, so now let's go over to 14 to 15-year-olds. How many rode the bus? 12. How many did not ride the bus? How many did not ride the bus? How many?
13.
13. Stop talking. How many total is that?
25.
25. Okay. Next interval, 16 to 17-year-olds. How many rode the bus?
14.
What is it?
14.
And how many did not?
21.
Okay, so how many total is that?
35.
35. All right. So now I need to get my totals for, doesn't matter what age, how many rode the bus and how many did not ride the bus. 24 plus 12 plus 14 is? Okay. 50. And what's 16 plus 13 plus 21? 50 again. All right, so now I need to check my marginal frequencies. How can I check to make sure my totals are correct? Elizabeth?
Add 50 plus 50 and 40 plus 25 plus 35.
Right, and Maya, what am I looking for?
The same.
Yes, very good. The same totals for both of these. Do they both equal 100? Okay, so I know my marginal frequencies are correct. All right. And one thing I want to point out on the interpretations, based on my totals, it's kind of difficult to really even make an interpretation. Would you agree? I mean, 40, 25, 35, the same number of students were not surveyed from each age category. Okay, so I can't even say, oh, well, fewer or more students are riding the bus because the same total of students was not surveyed in each age group. So when I'm looking to make an interpretation, sometimes, and this is what we're going to do in example 4, sometimes it's better to look at percentages. All right? So percentage-wise, now, how many 12 to 13-year-olds rode the bus? Okay, well, we know that there were 24 students out of how many total that rode the bus in that category? Out of how many total? 40 students. We just came up with our total, right? We said 40 12 to 13-year-olds, were surveyed. They were asked, do you ride the bus or not? And out of those 40, 24 of them said, yes, I do. So what percentage of 12 to 13-year-olds rode the bus versus not? How do I change a fraction to a percent? How do I change a fraction to a percent? Change it into a decimal. 24 divided by 40 as a decimal, and then we convert it over to a percentage. So what's 24 over 40 as a percentage?
60%.
What is it, guys? It is 60%. Okay? So if 60% of the 12 to 13-year-olds rode the bus, what percentage is not going to ride the bus? You got to get to 100%. 40%. Okay? Because your percentages, you have to have 100% of the students, right? So if 60% rode it, that means 40% of this age group did not ride it. Okay? So once you find one, you can just fill in the other one. All right? So what about 14 to 15-year-olds? How many rode the bus out of the total of 14 to 15-year-olds? How many? 12 students out of how many total from that category? 25. So we need to find the percentages for this age group. What percent of students rode the bus?
48%.
48%. And what percent did not ride the bus? Well, if 48 rode it, that means 52% did not ride it. Okay? Now I want you to do the last interval. Find your percentage of students who rode the bus versus did not ride the bus. All right, so I had 14 out of 35 students who rode the bus and 21 out of 35 who did not ride the bus. That's going to be 40% and 60%. All right, so 40% and 60%. So now I need to make a conclusion about the data. Now that I can see, because I didn't have the same totals, I couldn't really say, well, more students rode versus not, or I couldn't really see much. But now for riding the bus, what percentage of 12 to 13-year-olds rode the bus? 60. What percentage of 14 to 15-year-olds rode the bus?
48.
What percentage of 16 to 17-year-olds? Do you see a trend in the percentages? As the age increases, what happens to the percentage of students? It is decreasing. Why do you think that is? Because they can drive. They're getting older. So as age increases, the percentage of students riding the bus decreases. All right, percent of students riding the bus decreases. All right, you can't say totals, you can't say number because, again, there were different values in each category. So we had to look at percentages. All right, and if you understand that, that's everything you need to know for section 6.3.